In a previous video, we took a look at regeneration failures, specifically the typical causes of regeneration failures in parts and assemblies, what you can do to prevent regeneration failures, and a 3-step process for fixing regeneration failures. In this video, we're going to take a look at some practical demonstrations of how to use that 3-step process in order to fix regeneration failures in some parts and some assemblies. So first off, I have a part open, and I notice that there is some red in here indicating regeneration failures. So for step number 1, I'm going to figure out what's failing. And to do that, one tool that we can use is the model tree. So I see that there is a protrusion failing. It isn't even highlighting, so it's not even generated in the model. I also see that there's faint red next to this pattern in the model tree. If I expand it, I can see that there is a hole in dark red that is failing. And again, I'm not sure where it is. And also we have a round that is failing. And if I take a look at the lower right hand corner of the screen, we have the notification center, and the notification center is telling me that I have 3 regeneration failed. And if we open the notification center, we can expand this, and we can see that inside of here we have the protrusion that's failing, a hole that's failing, and a round that's failing. So I have 3 different failures I need to take care of. So now that we've completed step 1, we figure out what's failing. Now we're going to figure out why it's failing. And so some of the different tools that we can use to do that are the feature information tool. We want to educate ourselves on these features. And first off, I will right click on this feature and go to information, feature information, and I'm just going to read the information in here. And so it's telling me that, hey, this protrusion failed regeneration. I'm not even really sure what it is yet. And it could not intersect part with the feature. Okay, the next thing that we see in here, the parents of the feature. So I see 2 datum planes and 2 other protrusions in the model. And by the way, I can collapse the model tree and rearrange this. And if I want to figure out, hey, what's this protrusion, I can click on it and I can see, all right, looks like it's sort of like the main cylinder there. And this other protrusion, okay, looks like it's that surface over there. So now I have a general idea of where it is in the model. And then I continue reading with the feature element data. So now I see that this is a helical sweep. All right, now I start thinking helical sweeps. Well, sweeps, they're not allowed to self-intersect. That's one of the biggest causes of failures. And so I continue reading on in here and I see, okay, here's the pitch value, 0.03. All right, that's good. And that's all I see inside of there. And let's see, it's got a profile and a sweep. Yeah, that's what defines a helical sweep. And then I see a bunch of different dimensions in here. So, I've got some information in here, not really seeing it. And let's go back over here. Another tool that you could use, you can right click and choose Information Reference Viewer. Again, number 1 cause of failures is parent-child relationships. And we can see that this protrusion actually has a whole bunch of different parents in here that generate it. Wow. I'm not even sure where to begin there. You know what? I'm just going to go and edit definition and see what I can tell from here. So I'll choose edit definition. And here's one thing I see. It's like, wow, this is a really old model. I don't even get a ribbon interface when I edit definition. For really old features, you get the model dialog box that consists of elements and action buttons. And so I see, okay, attributes, constant pitch, that makes it easier. Right-handed through axis. Okay, basic settings for a helical sweep. There is a sweep profile. Let's take a look at it. I'll select it and choose define and modify done. Let's go to our sketch orientation. Okay, so I can see where this is created. So we have our direction of our feature, and it looks like there is a line here. If necessary, you could switch from shaded mode to a wireframe mode, and we can see, okay, here it starts up over here and goes down this distance. All right, starting to get some information, and really it's just a straight line, so I'm not really telling that much about this feature. But I've gotten all I can get out of the sweep profile, so let's hit cancel since I didn't do anything. Next up, we have our pitch value. So pitch is 0.03, and sweeps generally are not allowed to intersect, specifically helical sweeps. So I had to make sure that the section of the feature is less than that pitch value. So let's select the section and click define. And now when I go in here, take a look at the dimensions. Hey, wait, this is 0.5875. This is way too long for the given pitch value. So I could either change the dimensions to make this smaller than the pitch or change the pitch. I figure changing the pitch is probably easier. So let's cancel out of here and let's change back to a shaded mode just so I can see everything. And let's double click the pitch value. And I think if I make it twice as big, 0.06, that should be good. And now I'll click OK. Hey, and there we have the feature. So again, took a look at it, saw that was a helical sweep, saw our different profile values, figured out what the problem was. All right, so we have 1 down, 2 to go, 2 regeneration failures. Let's just go to the next one in the list. And I see that we have a hole in a pattern that is failing. Let's take a look at the pattern. I'm going to select it and right click and information, feature information. And so it is a leader of an 8x1 dimension varying pattern. Okay, so we have a varying pattern and it's a dimension pattern. All right, so got some information about that. And so we have 8 instances in the first direction. Regeneration method is varying, and we can see the dimension values. So displayed value is 15.83.4 minus 60. I'm not sure what's going on with this stuff. So maybe I can get some more information if I just edit definition. Again, sometimes you'll find that you'll just jump right to edit definition. And so we're trying to create 8 different instances in this pattern. I can guess that this is probably the lead one. 1, 2, 3, 4, 5, 6. If I go to the Dimensions tab, they're modifying a dimension in here and giving it an increment of 60 degrees. And the dimension that's highlighted is this 15 dimension. So I'm trying to create 8 instances 60 degrees apart. Well, that would end up going past a full loop. I'd end up getting instances on top of each other. And so there are 2 different things that you can do in this situation. First off, you could change this from a variable pattern to a general pattern, and that one would allow intersection of these different instances. Or I could get a little better at math and figure out, hey, rather than having 8 instances 60 degrees apart, I should probably have 6 instances 60 degrees apart, and that would end up giving me around 1 revolution of the axis. Or you could change this from a dimension pattern to an axis pattern. One caution against doing that, though, is that when you change a pattern from one type to another, the geometry IDs and feature IDs change, and so that can cause unexpected failures in children of the feature. So for that reason, I'm just going to leave this as a dimension pattern, change the number of instances. Let's hit the check mark, and hey, no more red in here. Everything's good. We only have 6 holes in our pattern now, and we're down to 1 regeneration failure. All right. I'm going to go back to shading with edges. That's how I prefer to view my models. And we have 1 more failure, and it is a round. Let's select it and right click in information, feature information. And okay, this round failed regeneration, could not intersect with the part. And okay, it's just a simple round. It's got a radius of 0.01, pretty small value. And okay, it's on a layer that's shown. And it's got some different parents. Let's see what its parents are. So let's again rearrange this. Let's collapse this, maybe make this a little narrower just so that I can zoom in over here. And we can select, okay, so there's one pattern, that feature over there. Okay, then it's this cylinder over here and something over there. All right. Well, again, a lot of times what I find what's easiest to do is to select it and let's edit definition. And again, really old style feature, and it's got constant edge chain in here. Let's see, here's the references. And if I double click on the references, please confirm to remove chain with missing references. I'm going to cancel out of here. You know what makes me feel more comfortable? Let's see if we can use our old friend edit references. And edit references. All right, so hey, this is showing me something. It's looking for an edge over here, and it looks like that edge was removed by the chamfer. Let's select the second edge. Okay, so it's trying to go on that edge over there. That should be fine. And this edge over here. And so what I'm guessing is someone decided to put a chamfer in here instead of having a fillet around on that outside edge. So that must be the problem. So I could either change the reference for this to maybe this other edge, or edit definition of the feature in order to put it on a different edge. And so by changing the reference, hey, now we no longer have any failures in our model here. So there we applied the process for fixing the 3 regeneration failures in our first model. All right, now for our second example. So again, I can see that we have some failures here in the model. And again, they are with some patterns. And I can see that we have an extrude that's failing, and we have 3 draft features that are failing. If I go to the notification center, again, for regeneration failed, and we've got that, extrude and a few different draft features inside of here. All right, so again, let's take a look at our feature that's failing. I'm going to right click and choose information, feature information. Again, just educating myself on this. All right, and so we can see the different parents of the feature. And let me again try to rearrange my screen. So there's some edge over there. Okay, there's an extrude over here, datum plane called side, and this cut feature. So those are the parents of the feature. And let's see, it's member 5,1 in a 5x1 dimension identical pattern. Okay, so that leaps out at me, identical patterns. Identical patterns have the most restrictions to them. Remember, they have to have the same dimensions and shape as the original feature. They have to originate from the same surface, and they're not allowed to intersect one another. So again, they have the most restrictions, and those are the kinds of things that can cause them to fail. So let's take a look at that. Maybe I'm going to see how changing the options could affect this. So let's edit definition. And all right, I can see that this is trying to create, looks like 5 instances with a distance of 0.25, and it looks like the lead feature starts over here, but then wants to run off onto some other different surfaces over here. So maybe instead we should take a look at the options and see if changing the option might help things. So again, I don't think they're going to end up intersecting, so I could go with the variable option instead and hit the check mark. Hey, and that fixed the extrude and also fixed the draft. The draft feature must have been a reference pattern on top of the original pattern. So again, patterns, you might want to take a look at the different options that were used to create them. In this third part example, I'm actually going to create a failure and then show you how you could prevent the failure in the first place. And so we've got a part over here, and we can see that we've got this octagon cut in the middle. And let's say I know that this part is going to be molded or cast, so I need to have draft on those surfaces in order to be able to release it from the mold. And so in order to do that, I'm going to create my draft feature, and I'm going to select the 8 surfaces that I want to apply draft to. And I am selecting them manually. So 1, 2, 3, 4, there. There I have all 8 surfaces, and let's right click to define our draft hinge. And for the amount of draft, let's see, I'm not sure which way this is going to be pulled out of here, but let's say it's this way. Let's put like nice 5 degrees of draft, nice big value on that surface there, and hit the check mark. Okay, so I create my draft feature, no regeneration failures, everything is good so far. Let me show you how you can end up with a failure in the model. And let's see. So here's the octagon sketch. What I'm going to do is I'm going to edit definition of this. And let's say that we have a design change that requires this now to be a circle instead of an octagon. I'm just going to swipe a box over all the different entities and go to hit the delete key. And let's define a circle. Look about over here. That's good. And for the sake of this demonstration, I'm just going to hit the check mark and get out of here. And now all of a sudden I get a regeneration failure. And that's because the draft feature is looking for a bunch of surfaces that are no longer in the model. I use the edit references command to show the different missing references inside of here. Similarly, if I edit definition, and if I go to the References tab, you can see that there's a red dot next to individual surfaces, indicating those are the missing references. If I go to the Details button, we can even see the outline of what it was looking for. So let's cancel out of here and cancel out of here. And I am going to undo a couple of steps to show you how to prevent that from happening in the first place. All right, so again, we need to apply draft on these different surfaces. Let me show you how you should do that instead. I'm going to hit the draft button, and instead of selecting the surface, I'm going to tap the right mouse button until I get what's called the intent references. And you can see in the little tooltip, it's telling me that here I'm grabbing the intent surfaces. So what I'm doing in this situation is I'm grabbing the surfaces associated with this feature, not the actual explicit 8 surfaces themselves. And I have selected them. And just like before, let's define our draft hinge as this surface. And let's make it a nice big 5 degrees that you can see. 10 degrees, that's good. I really don't care the value. All right, so I've done that. And so now I've got my draft applied to the octagon. Let's select the octagon, and I'm going to edit definition. And just like before, I'm going to delete all these different entities in here. And just to be a little interesting, let's put in a center rectangle over here, and like yay big. And again, for simplicity, I'm not going to change the dimensional values. I'm just going to get out of sketch mode. And you can see that this time the draft feature didn't fail because it automatically updated the references of the draft feature to be the intent surfaces associated with that feature. Now for an assembly example. And so I open up this assembly and I see a lot of red over here. So if I expand this subassembly, okay, looks like there is a problem with this rear disc part. And if I expand this one over here, okay, there's an oil pump issue, spark plug issue, bunch of other components are in light red. I assume that they're assembled to something that's failing. Same thing with this scoop part over here, fuel line. Boy, there's a lot of red in here. What the heck is going on in this model? And if I go to the notification center, I see that, okay, we have 2 regeneration failures and 11 missing models. Let me click the notification center, and okay, so a bunch of these different models are missing, and we've got some different other failures happening inside of here. All right, probably the easiest thing to do is to start and try to figure out the issues with the missing models. And as always, I recommend that you probably want to try to start as high up in the model tree with the failures, or you could go for the low-hanging fruit, but usually I prefer to go for the higher features because a lot of times that can help. All right, so I can select this CB22 rear disc part, and if I right click on it, here we have the option to retrieve the missing component. This is one of the parts that it cannot find. So I'll click on that, and I'm going to navigate in my computer. Oh, what the heck folder is this in? Okay, and so in this case here, it's looking for a file name of CB22 rear disc, anything with that somewhere in the name, and I navigate to this folder, and here is that file. And what's interesting about this one, I'll go and click the open button. When I find that missing file, it ends up fixing a bunch of the other regeneration failures. And the reason for that is that if there are any, it sort of like adds that folder now to the search list. If any of the other parts in this model had missing components, it'll look in that folder as well. And I'll take a look. Okay, there's a circular reference. That's really bad, but at least it's not a regeneration failure. Actually, it could be worse than a regeneration failure, but anyhow, all the regeneration failures are fixed. One other thing to note is that in Creo 6.0, we now have this indicator that the model needs to be regenerated. In earlier versions of Creo Parametric, you'll have a traffic light, and the traffic light would show yellow when you need a regeneration. It would show red when you have a regeneration failure, and the traffic light would show green when everything is good. And I hit the regeneration, and okay, we still get, okay, goes back over there. So now we no longer need a regeneration because that symbol went away from our message area. All right, another assembly example. And here I see red in the model tree, so it looks like there's a problem with the brake assembly, and it looks like there's a problem with the spindle subassembly. Oh, it looks like this bearing is in red over here, and also looks like the bolt is in red. Again, we can go to the notification center, and it says that we have 3 regeneration failures. And when I have a failure in a subassembly, I prefer to just open up that subassembly and deal with it on the lowest possible level. And so I can see that we have these little notification symbols. You can also hover your mouse over, and it tells us, okay, we have 2 regeneration failed notifications in and below the item, and also something with the spindle. If I look inside of here, okay, looks like, geez, there's a whole mess of problems in here. Let's go and open up this part. Sometimes you'll have regeneration failures and you'll have to fix the part. All right, let's edit definition of this pattern of holes. And, okay, we can see that, looking for a hole over here. All right, dimensions, 1, number of instances. Okay, so 1 with an increment of 72 degrees. I don't know, let's hit the check mark. Let's take a look at the original hole and edit definition of it. And all right, so now we can see over here that hole created about 360 degrees, 0.375. Looks like the diameter. And hit the check mark. All right, let's cancel out of here. Current selected depth reference is invalid. All right, let's resume. And for the depth reference, looks like it's looking for an external reference for the depth of the feature. So let's try to change that. Instead of to selected, for simplicity, I'm going to use through all and hit the check mark. And so, oh, that took care of the failures in here. So here's an example where someone was trying to do something probably with an external reference, and I open up the part, it can't find the external reference. Then we have to either use a local reference or use something different instead. And I'm assuming that by using a through all depth, that should be okay in this situation. I don't know the original design intent, maybe it's not correct, but anyhow, I'm going to leave that as is for now. All right, let's close out of there. And so now I take a look inside of the spindle subassembly and the bearing. Okay, we can see that placement is in red. There must be some problem with the placement of this component. Let's edit definition, and now it says fully constrained. Sometimes when you have an issue and you change some geometry, probably just needed to regenerate or edit definition, and now everything seems fine at this level. So that's good for the spindle subassembly. Let's close this. Oh, don't need that part anymore. All right, back to the wheel assembly. And I can see that we probably need a regeneration. Click regenerate. Oh, well, what do you know? So by fixing the problem in that spindle part, it took care of the problems in the pattern, and I actually don't see any other regeneration failures in here. So that way we have fixed the problem. So again, just to reiterate, you want to figure out what's failing, you want to figure out why it's failing, and then you want to fix the problem. And as you see, in some of these different situations, you fix one regeneration failure, and that fixes multiple regeneration failures in your models. I hope you enjoyed this video. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button to be informed when new videos are uploaded. Thank you very much.